Hello, I want to talk about what the graph of this looks like first, and then we'll go in the techniques of how to get it. And I want to start with this notion of the parent function x squared. And we know what that looks like. That looks like this. And this is symmetric to the y-axis, which is the line x equals 0. So right here. So what that means is that if I pick up this side of the graph and put it on that side of the graph, it matches perfectly. Now what I'm going to do is I'm going to change this graph so it looks like this. And I'm going to use the ideas about graphing that we talked about in a previous class. So the first thing is to take y equal ax squared, and that's going to stretch or shrink. So in other words, it's going to make it go narrower or up. And I'm not going to worry about how or exactly how, but that's the point. Now notice that doesn't change the symmetry. So now the graph, if this were y equal x, y equal ax might look like that. Okay. Okay. But again, the symmetry remains the same. The symmetry hasn't changed. Now we're going to move it to the left or right. And so what I'm going to do is I'm going to add a plus or minus k there. And that's going to move this to the left or to the right. So for example, what my graph looks like, if this were y equal ax squared, my new graph might look like this. I've moved it over. Okay. So again, I still have the same symmetry properties. This line is still the line of symmetry. Notice my vertex here is 0, 0. My vertex here is still 0, 0. My vertex here, I've moved this over h. So my vertex is now going to be h0. Okay. So one more piece to this. Again, I'm just trying to keep as much of the graph on as I can. The third thing is I'm going to add my k to it. And that's going to move it up or down. So here's an example now. Here's my original graph. Here's the graph what happened when I moved it over. And now I'm going to say move it up k. So now I've moved it up k. So the graph would now look like that. This is my point hk. This is my line of symmetry, x equal h. Okay, it's still the line of symmetry. So basically what I'm trying to say is that we start with the parent function and we transform it to the standard, to a generic form like that. Ax squared shrinks or stretches, but still has vertex 0, 0. When we add this term here, it moves it to the left or right. Here we moved it over to the right, h units. The graph is still symmetric. And now when we add the k, we move it up or down. And again, so this point, hk is the vertex. So that's kind of how we get the graph. So then the question is then going to be, is that given ax squared plus bx plus c equals y or f of x, graph it. And I think the best method is to transform it so it looks like this. And there's a couple of methods to do it. One is you can complete the square, but I'm going to show you a different way. I might show you the complete the square later, but I want to show you a different way. I'm going to just do it by direct comparison. I'm going to compare this to this. And then I'm going to give you a formula for finding h and k. Okay. And we're going to start with the example that we used before. So we had f of x, y equals f of x equals 3x squared plus 7x plus 11. We're going to keep that one in mind. Okay, so I'm going to come back to that. But here, what I want to do is compare these two things. Okay, and that's going to give me my formula. So we'll do that over here. I'm going to rewrite. Again, any parabola like this, if I think about it, all it is a stretching, a moving left or right, and a moving up or down of x squared. So we know that we can take it, any parabola looks like this, or it looks like this. We're often going to be given it so it looks like that. I want to show you how to find h and k. So what I'm going to do here is I'm going to square this out, and then I'm going to compare what I get here to that. We're going to get a formula which you can use. I just want to show you where the formula comes from. I think that's important. So I'm going to square this x minus h squared out. Again, reminding you that's x minus h, x minus h, and I'm going to FOIL it, x squared, then x times h is the second thing I'm going to do. I'm going to do this one, minus h times x, and then the last one will be, the fourth piece will be that. So the first thing, x times x squared. The second, minus x times minus h. The third, minus h times x. And the last, minus h squared. This gives me x squared. Oh, I'm sorry. I forgot to do something here. I just wanted to do this piece right here. X squared minus 2x plus it. That's what this in between the parentheses means. And I want to show you just a shortcut. No, I'm not going to do that. I'm just going to go from here to here. Okay, so the first step, I take this, and then I square this out, and I get this. And then plus k. Now, I'm going to distribute the a. Sorry, that square should be here. Okay. So notice I have, if I rewrite this, that this is my b right here. And this is my c. So we say b is equal to minus 2ah, and then we have ah squared plus k is equal to c. Now we need to figure out what h is. Well, I can solve. That cancels, so I get b minus 2a is equal to h. And then over here, I can solve for k. I subtract minus h squared from each side. And I get k equals c minus ah squared. So those are my two key formulas. I'm going to rewrite them on the next page. So what we showed is that given y equal ax squared plus bx plus c, so started here, what I found by doing all this algebra was that h is b over minus 2a. I gave you that formula in the last class. And that this k is equal to c minus ah squared. And our vertex is hk. So again, you don't need to understand where these come from and all the details, but I would like you to understand a little bit about how I got it. And remember, what I did is I started with this, I squared out this, I realized that figured out what A, B, and C were in the new version, and then I just was able to solve for those. Okay, so here's my example. This is really what matters. We're going to graph y equals ax squared plus bx plus c. Now, when we graph something, we want to find, when we graph this parabola, we want to find the vertex. We also want to find, if possible, the y-intercept, and if possible, the x-intercept. Now, to find the y-intercept, remember, you just plug in x equals 0. Okay, so that's what we're going to do here. So this, again, this is graph that, we need to do that. So here's my example. Y equals 3x squared plus 7x minus 11. I'm sorry, it's plus 11. This is what we did in the first video. I'm going to use my formula. I want to find my HK. I want to find my vertex. So my vertex is going to be H equals B over minus 2A. Well, B is 7. A is 2, so it's going to be over minus 2 times 3. And then K is going to be equal to C, which is 11, minus A, which is 3, times my H squared over here. So I'm going to see that H is equal to 7 over minus 6. So K is going to be 11 minus 3 times 7 over minus 6 squared. Okay. Well, that's going to be 11 over minus 3, 49, 36. I simplify that to 12. K is going to be equal to 11 minus 49 over 12. Again, that's going to be equal to 11 times 12 over 12, finding my common fraction, minus 49 twelfths. I'm running out of room, but this is going to be equal to 83 over 12. When I simplify all that out, I'll let you do the work. So my H is there, my K is here. Now, so I've got my vertex. Now I need to find the y-intercept, so I plug in x equals 0. F0 equals 0, 0, 11. So my y-intercept is 0, 11. Now we're going to see if there's any x-intercepts on the next page. So again, I'll summarize things on the next page. We have y equals 3x squared plus 11, plus 7x plus 11. We went through the work and we found that h was minus 7/6. K was going to be 83 twelfths, which is just under 7. And we found the y-intercept is going to be equal to 0, 11. So the graph, I'm going to do a rough sketch here, x, y. We know the y-intercept is 0, 11. And we know that hk is going to be minus 7/6, 11, minus 7/6, 83 twelfths. So the graph is going to look something like this. Again, this is a rough sketch. Here. That's going to be the graph of y equals 3x squared plus 7x plus 11. And that's it. Again, it's a rough sketch right there. Okay, I'm going to do another example in another video. So thank you.